Okay, for lesson 2 from unit 4, let's warm up by practicing our foiling real quick. 4x times 4x is 16x squared. 4x times 3 is 12x. 3 times 4x is 12x. 3 times 3 is 9. Combine like terms, 16x squared plus 24x plus 9. 4x squared plus 14x minus 14x minus 49. Combine like terms. Positive 14x minus 14x makes them go away, and you're left with a 2 term. So when you have the same in front and the same in back but positives, you get 3 terms, just for curiosity's sake. And same thing in front, same thing in back but opposite terms, you actually end up with a binomial sometimes, okay? Well, specifically for this kind is a binomial, but that's what we're going to talk about today. So right now we're practicing our foiling. There's 2 negatives. 2 negatives multiplied makes a positive. So 2 of the same gives you a trinomial. Different signs. You may get, in circumstances, you get a binomial, which is something we're going to talk about today. We're just regular foiling. You get what you get. Okay. We also want to review our squares and our square roots. So remember, 1 times 1 is 1, so the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3, and so forth. Remember, if you don't know 1, you can put this in your calculator. You hit second and see how there's a little square root above this number. You hit that and you put 36 in there and enter. The square root of 36 is 6, and so forth. So if you want to either figure out how to do it on the calculator or keep these in your notes. And then when you're square rooting an x squared, remember x times x makes x squared, so that's an x. Square root of this is the same as the square root, square root of 4 times the square root of, I'm just explaining, so this is going to be a 2x, okay? Like this one is a 4a, this is a 8v, this is a 9t, okay? So you think about the square root of 81 and the square root of t squared. So this is 9 times 9, which means that's a 9, okay? And this is t times t, so that's a t. So your answer is 9t, okay? So I just want to point out that when you're looking at the difference of squares and perfect squares, it's just something a little extra to think of. So we were doing all trinomials. When we're identifying and factoring the difference of squares, notice a couple of times on our warm-up we had a square minus a square, okay? And that's going to give you one of each. So this one here, it's not a trinomial, it's a binomial, but we're still going to end up like starting like that. So you might want to add, remember for trinomials, 2 pluses get you 2 pluses. a minus and a plus. You have two minuses in your answer. A plus and a minus, you have one of each. A minus and a plus. Oops, my apologies. Trying to do something fast. Minus minus gives you a plus and a minus. Well, add to that, if you have just a minus, you're going to have a plus and a minus. Okay, so a plus and a minus, and then the square root of 16. So the square root of x squared is x and x. The square root of 16 is 4 and 4. There's your answer. Okay, if you have two variables, remember we're still trying to do this, and our signs, if it's a binomial, is a plus and a minus, and then these just go here. That's all. That's your, I don't even know how to show any work other than all perfect squares minus perfect squares. Subtracting two perfect squares will always factor the sum and the factor to the sum and the difference of square roots. So look at this one here. The square root of 9a squared is 3a, right? The signs, when it's a perfect square minus a perfect square, or the difference of squares, is 1 plus and 1 minus. The square root of 25 is 5. The square root of b squared is b. There's my answer. Okay? The sum of squares is always prime and cannot be factored. Cannot factor. Just wanted to mention that. And these two here, if you have a perfect square plus perfect square, you're going to get two of the same. So here's a trinomial. X, X, my signs are plus and plus, therefore my answer is a plus and plus. And if that's a perfect square, if C equals a perfect square, then one thing to guess would be the square root of that. So 7 and 7, which is going to give you the same thing. Think about it. 7x is 14x. 7 times 7 is 49. Okay? So sometimes you'll see that answer as that. Okay? Here's a trinomial. X, X. An X first and then a plus is a minus and a minus. 9 is a perfect square. So square rooted is a 3 and a 3. This will be negative 3x plus a negative 3x will give you the negative 6x. So you will see this like that. Okay? If you have two variables, so this is just a little extra something that we just went over trinomials in the last lesson. So double variables, first, last, plus plus is a plus plus, and then a perfect square would be a 5 and a 5. 5 plus 5 is 10. 5 times 5 is 25. So our final answer will be this squared. Sorry, that's my washer in the background. Last one, X minus plus is a double minus. Perfect square, a 2 and a 2. A 2 times 2 is a 4. A negative 2 times a negative 2 is a 4. And a negative 2 plus a negative 2 is a negative 4. So this answer is this squared. Okay. So these are pretty easy. You should be able to do these, you know. So let's practice real quick. There's not much work to show. I have a binomial, a perfect square minus a perfect square. So a difference of squares. So square root here, and the signs are a plus and a minus. Done. Perfect square minus a perfect square. 5x plus minus 6y, 6y. Done. Right? These are not the same, so we're not making that a square. These are different. That's my final answer there. This one here is a 2x plus a 9 and a 2x minus a 9. Done. Here's a trinomial, W plus plus, perfect square, 3, 3. 2 3s make a 6. I don't know why there's so much space here, but they're pretty easy. Trinomial, W. Let's see, perfect square on the end with another variable, x, and since 5 times 5 is 25 and 5 plus 5 is 10, the negatives first, which means there's a double negative. So this one, there's 2 of them. Get the difference? This is a perfect square plus a perfect square. Does not factor.